Hello everyone. In this video, we're going to learn about thermodynamics. We will focus on subtopic 14.1, First Law of Thermodynamics. The first law of thermodynamics is the study of how energy can be exchanged between a system and its surrounding. Any system can exchange energy with its surroundings in two general ways as heat or work. This will affect the macroscopic properties of the system like pressure, volume, and temperature. First law of thermodynamics. It is a statement of the conservation of energy for a thermodynamic system. First law of thermodynamics states the heat supplied to a closed system is equal to the increase in the internal energy of the system plus the work done by the system on its surrounding. Expressed mathematically, we have Q is equal to delta U plus W, where delta U is the change in the internal energy, U final minus with the U initials, Q is the heat added into the system, and W is the work done by the system. However, heat might flow out and the system might do works. Therefore, we have to use the correct sign convention when using the first law of thermodynamics. For the sign convention of Q, delta U, and W, when the system absorbs heat or heat flow into the system, Q is positive. When the system loses heat or heat flow out of the system, Q is negative. When the internal energy increases or T increases, delta U is positive. When the U decreases and T also decreases, delta U is negative. Work is done by the system and the system doing work by expanding, W is positive. When the work is done on the system, that means the system undergoes compression, work is negative. So be careful to use the correct sign. Let's see one of the example to solve using the first law of thermodynamics. So we are given 100 joules of work where the work is done on the system and the internal energy increases by 74 joules. So does the gas system gain or lose heat and how much? So we have to use the first law of thermodynamics. So Q is equal to delta U plus work. By referring to the equations and also referring to the sign convention, the internal energy given is increases by 74 joules. Therefore, delta U is positive. How about the work done? So work is done on a system. So work here is negative. So we have to substitute 100 with negative 100. So calculating to get the amount of heat, so Q is equal to negative 26 joules. So the negative signs here referring to the system that loses heat. So the heat Q added to the system, to a gas system, is used to change the internal energy of the gas, to do work on the gas system, or both. So how do we know that there is a change in the internal energy or not? So we can refer to the change in temperature. So remember delta U referring to the delta T. So, and the other one, how do we know if there is a work done or by the gas system? So we can refer to the change in the volume. So remember work and volume. Okay, so now you may try pause the video and do the example yourself. Okay, see you on the next subtopic.